We're doing something a little bit different here today. We're going to tape a brown bag seminar. If this goes over well, I'm going to try to do 2 or 3 more of these in the next year. Today we're going to talk about site reconnaissance soil borings. So it's not as easy as just picking up the phone and calling Tom Bama from AET and Al Hartwig from AET are here. I'm sorry, I should introduce them. I started to work on a presentation on what we should be doing for site reconnaissance and the information that we needed to get him involved. And lo and behold, Tom was thinking he should come back in and talk about how to interpret the soil borings and what the recommendations mean. And I don't know, I was probably about halfway through putting together my presentation when Tom and I touched base. I said, why don't we do this jointly? And oh, by the way, MnDOT's made another change to their bituminous specifications. I think it's about the 3rd or 4th in the last 5 years. And we have a hard time keeping up with that. So we asked Al to come along and kind of give us an overview on what the changes are and what we should be looking for, because one of the biggest challenges we have is we can get 4 bituminous contractors to give us pricing. They're all going to give us what they think we want, and it's not what we want. And they're driving their prices down as much as they can, and in the end, sometimes we get stuck with an inferior product. So hopefully we can shed a little light on that as well. So today we're going to talk about site recon and soil borings, and what we want to do is to figure out what it is that we're going to want on this site early on. And one of the most important things that I do is a desktop study before I even go and visit the site. I'm pulling up Google Earth, especially if this is a project staying in the middle of Ohio. Instead of spending a couple of grand on a trip out there, it's really not accomplishing anything. I try to get as much done sitting at my desk as I possibly can. Pulling up Google Earth, we have a vast network of geotechnical engineers, civils, and other contractors across the country. I'll start making contact with those folks and find out what the local conditions are like, and maybe some of the challenges are working in winter. Are the soils wet? Are they sandy? Is there a lot of rock? Those kinds of things you can do an awfully lot just sitting at your desk before you get going. And actually, quite a few of these slides are from our site up in Montreal. So David, I didn't get permission from me to use these, but I did it anyway. Sometimes you come rolling up on a site in the highest spot on the site you're flooding ducks out of. So I can tell you right now, this is going to be a challenging site. It doesn't take a genius to figure that out. Okay, so what you're looking for when you first roll up is indication of what the site's going to be like, and obviously standing water is going to tell you a lot. Does this look natural to you? No, it's not. Okay, so you've got to be aware that somebody did something to this site, and flags should be popping as you're getting ready to engage the geotech. He needs to understand that somebody's been doing something out here. If they've been dumping excess material or debris or whatever on the site, who knows what they've done out here? They could have dug bottle pits and done all kinds of things here. Again, this is the Montreal site. You can see just piles of debris in an old farm field. Lack of vegetation will tell you that this has been disturbed. Okay, so you need to be aware that you may have some environmental issues here. You may have some soil corruption issues here.
And Larry and I are going to go back and forth through this presentation. So just this slide here, I'm going to talk about a site of mine that I have a project at GME. When you see something like this, you have tree cover, and all of a sudden you get into an area where there's no trees, or there's very young trees like cottonwoods or something. Red flag. Somebody has done something to that site. And like I said, I'm going to talk about a site in Plymouth where that very thing happened.
Yep.
And it caused a little bit of problems with the project.
And 80% of the time, what they've done with the site isn't real positive. So you've got to be aware of that. This is our West Jefferson, Ohio site. This is a visit that I took early on. Obviously, we built this thing on a farm field. Well, what in the world was that? Okay. So, you've got indicators where you're working in some undisturbed area. It's low lying. You know that you're going to be needing a lot of borrow. Is this a borrow? Is this, excess topsoil? Is it buried trees? You don't know. And you're not going to know by just taking a conventional soil board. So we took some other measures where we got up here with a backhoe during the early on in the exploration, got in and actually dug through that to see what we had. And it turned out we could use about 70% of the material that came out of that berm with a little bit of conditioning and used it as borrow on the site. We probably saved target north of $3 million off of their budget by, being aware of what this is and doing some homework up front, not just dissing it, throwing it away, thinking it was just excess topsoil from another project that was done.
Now I want to talk about, look at this farm field, it looks nice and flat. Up in Brooklyn Park, Ryan had a couple of sites up there where we had very deep topsoil. And what we found, like when we drill soil borings, sometimes our guys will drill the borings in the most convenient spot, which is down in the valley of the plow line. So we're getting a thickness like this, but the ridge to be like this. And then when you see a level farm field, a lot of times that ground wasn't level to begin with, so the farmer leveled it. So you're going to have pockets of deeper topsoil. So what we did up at Brooklyn Park, it was for modern manufacturers, we asked that test pits be dug. So Pratt alone came out, they dug some test pits, and sure enough, that topsoil was 2 to 3 foot thick. And it wasn't like in Brooklyn Park where it just went from a nice black sand to a kind of a gray sand. This was good black topsoil. So that site for balancing, now all of a sudden you got to cut it 2 to 3 feet, and this is dead flat already. So that it was an import situation and or a borrow pit situation, and where do you put this topsoil on that site? So that's where somebody like Larry is looking at this going, okay.
Can we overmine the ponds? Yeah. Okay, and if it is a borrow situation, do we spend a little bit of extra money on bringing in a granular material so we can thin up the pavement section? There's just a lot of give and take that you need to understand that we're here to help you while you're putting together your budgets, and the superintendents are putting together their schedule. There's a lot of opportunity in what you might perceive as a risk and an expense. I mean, sometimes we can turn that to our advantage. Back to, just looking at sites. This, again, was in Montreal, or near Montreal. We actually thought about building the distribution center underneath this power line. One of the early on site layouts showed that, hey, we can do anything. These guys are going to move this power line. Well, we can't. I mean, it's virtually impossible to do. So another thing that a site recon will do is to help you with site layout. And maybe it's not the right place to build what it is you're trying to build. Again, you got to look for indicators around the site for what might be there. Flags got to pop up and go. But one of the things I look at is vegetation that you might see. An oak tree, for instance, indicates it's a pretty free draining site. I love to see oak trees. Willow trees maybe indicate something that might be a little bit more wet and heavier soils. Scrubby spruce trees indicate shallow bedrock. I mean, as you look at more and more sites and get burned a little bit, there's a lot of tuition that goes into that. There's a lot of things that a site can tell you just from powers of observation and experience. But feel free to use them anytime you want to. So we're going to move into a little bit, and one of the other things that I like to do when I'm visiting sites is looking for ongoing construction. You can learn a lot about how, especially on an out-of-town or out-of-state project, you can learn a lot about how things are done there. On this Ohio site, looked at an adjacent site, I saw a line train where the contractor was using quick line, had a rototill going, picking this material up and going. That indicated to me that, you know what, it's not going to be easy to build here. It's going to be a little bit expensive, but pay attention to it. The predominant paving in that area was concrete. Why is that? So you start asking the smart questions, and maybe you can eliminate a lot of mistakes just by paying attention. Sometimes looking at the different kind of landscaping, you pull onto a distribution center, a warehouse, and you go, geez, this is pretty nice. A lot of rock, a lot of retaining wall, a lot of irrigation. A lot of indicators that will help us while we're putting the budgets together, just by paying attention to what's going on around here. Okay. Now, one of the things that as we get into the soil borings, I do not like to see final reports issued until after the bids are done. Sometimes that's not possible, but as Tom and I will start to talk about, we want to keep these as preliminary borings, reports, whatever it is, until we get with the contractors and start getting into their heads on sometimes, changing grades a little bit, going with a different kind of a pavement, or just a lot of things that we can boil in to as we're sitting down together as a team, especially if we can take the contractor that we're going to be using for the site work to help him with that last little push to get those soil reports finalized. He's got total buy-in to the scope. You don't get a lot of pushback with change orders and so forth, because they help. They know exactly what's going on out there. And feel free to ask me questions. I'm going to turn this over for a little bit to Tom, but go ahead, Gary.
So, Larry, in the geo reporting area, it's really just about keeping it open-ended so that you can build in means and methods into that final report that benefits with your low bidder. Is that what you're saying?
Yep, keep it open-ended. Sometimes, not Tom so much, but some of the other geotechs that we use are more about risk aversion for their company before they're taking care of Ryan companies. Okay, and I think you know what I'm talking about. You'll get some pretty ultra conservative looks at things that based on your experience really aren't right. And sometimes you need to have some justification and some motivation on the geotechnical engineer's part to move off of what their initial recommendations are. And so that process also helps them get comfortable that you know what you're doing. And sometimes you can get them to back off on, whatever it is that's causing you some heartache in their report.
And Gary, for example, on the Target North campus, I wrote the first report as preliminary. It was 2 months before I issued the final. And we went through, okay, you have an 8-story building up there. The column walls are a little bit too heavy to put it just on footings without ground improvement. So I gave a couple of options for ground improvement, not to lock it into one contractor. And then Dave Gotham did some checking, some bidding, and then Fradlone got on board for the kind of fill to use for balancing the site, so that by the time that I issued the final report, all that was set. And it just stops all the conversations at the job site, like, well, I didn't bid it that way, or, it's right there. It was a running document at that point. For some of these reports, things have changed so much that it's not that accurate. And then you get into charges for extras and things that aren't clear.
Yeah, well, that's one of the things too early on. By doing a site recon, if the site's flat, low-lying, you might think, well, this is going to be easy. Well, it's not, because generally you need to bring some fill in. I like to see a nice rolling site. And if we can take a shot at setting the finished floor elevations for the building that's going to be built there, it's to our advantage before we get the soil borings going, because what happens every once in a while is we're thinking this building is down here. Tom's coming out and taking a 20, 25-foot boring in the building pad, and all of a sudden we kick it up here, and we're not even really getting through the fill. These are nightmare scenarios, but kind of having an idea where the site's going to go and what the elevations are going to be before you get them on site really help you a lot. And there's other, long-term issues like settlement and so forth that you're going to have to deal with. And the more that you can understand how this site needs to be graded, the more of these different kind of tests that you can pull into to take care of the risk. That's what it's all about. These soil borings are about taking care of the risk.
And then like, I see Mark in the background. On the Sage site, that floor elevation went up and down for a couple of months. And I think the final elevation was set at like the cut and balance, and then where the wetlands were for drainage, and where I think Greg wanted the site to be. Is that pretty much right? Or?
Yeah, and it was also a timeline of trying to minimize how much fill we were bringing in. But you're right, tying into some of those wetland grades. So,
And I'm going to talk about Sage, and because when they finally did set that floor elevation, it'll allow us to do something pretty cool that I'm going to talk about here that really helped with the schedule and the building itself.
Any more questions about Site Recon? We brushed over, we could be up here for 2 hours just talking about that. But I want to pass this over to Tom and he's going to get more into what happens after we turn it loose.
And then Larry's going to interject as needed. So when we write a solar report, we got all these different people looking at it, and they're all looking at it for different reasons. And taking something a little bit different out of it. When we do a report, Ryan, I think the primary thing is to figure out, okay, is this a deep foundation site? And Larry had a term.
Well, we at this point, you know, the euphemism I use is let's kill the deal. I mean, that's literally what we're trying to do. Does this site make sense to build on? So the word you use is let's kill the deal. Is this going to be too expensive? Is it going to be too much risk to build whatever it is that you want to build here? So that's the filter you run through early on. And sometimes you're helping the owner or us buy the property at a discounted price because there's issues out there. Okay, so and after you bought the price at a discounted or bought the land at a discounted price, then you got to take that hat off and you've got to figure out how it is you're going to build the thing and do it economically. So there's soil borings are a good tool for that, but we try to kill the deal every time.
Or again, get the right price for the site. Then also, like for the civils, and Ryan has a civil department. Every site has some kind of stormwater management that you have to consider. So if we're drilling borings and we're on a nice sand site, hey, you can do infiltration, but if you're up in the road on a clay site, you're not going to be able to do infiltration. And then what Larry was alluding to before is, depending on if your site is, if you need to bring in fill, well, you can bring in granular fill for sand subbase for your pavements versus a cut site where if you're in a cut site in clays, it's pretty hard for the geotech to ask you guys to put in a foot of sand below a pavement, which means you got to cut an additional foot and haul it out. So you can work with the sites depending on where the grades are set. So that's where I think, and that preliminary versus final, there's a lot of good discussions that can happen as you're managing the site. Where are you going to set elevations to try to accomplish some of this stuff?
I can tell you the chances of us building on a clay site in October, November are pretty high. And a lot of decisions that we make are based on time of year as well.
So when contractors look at our soil reports, he's trying to figure out what kind of equipment he's going to use. He's going to have sheet split for clays, smooth drum for granular soils. He's also going to look at the moisture contents if it's a clay site. Like at Sage down in Faribault, and I'm going to show you a log that will show. When we drilled the borings in May, the moisture contents were in the mid-20s, which is a little bit over optimal for compaction. We went into a drought period towards the fall. Moisture contents dropped so that it wasn't such an issue with trying to dry the soil to get good compaction. The moisture contents are really important for a guy looking at this to evaluate, do I have to dry the soil? I mean, if I'm in a wet time of the year, am I going to have to dry it? Or if I'm trying to do this in late October, November, I can't dry it. I mean, it's not really going to be a drying time of the year.
Would you put back one slide? Where did I see shrink and swell? Was that
That's coming.
It's coming? Okay, sorry. One of the things too, let's go back to the construction slide. We can't get up in the contractor's business. Okay? Some jobs are going to be scraper jobs. Some jobs are going to be excavators, off-road haulers. Some jobs are dozer jobs. the soils are going to react differently to whatever it is that they decide to build that with. And one of the biggest mistakes we ever made was when we were building the distribution center in Cedar Falls, Iowa. Is in the soils report, we told the contractors what the shrink and the swells were. Don't know why we did it, but we ended up having to deal with it on 250,000 cubic yards of excess soil. So you need to understand what the shrink and swells are for Jared and his group to be able to achieve some site balance. But whatever you do, don't publish it because it's going to come back and it's going to bite you. So those contractors have to make those determinations of a 400,000 pound scraper fully loaded is going to make that soil react a little bit differently than a 100,000 pound off-road hauler. Okay? Just bear that in mind. Be careful what you should.
And then for soil engineer, like when we get to the later side, when we talk shrink and swell too, we're talking like plastic soil rather than shrink and swell. What he's talking about is earthwork volume calculation.
Yep. Yep.
So, and then sometimes I will put in one of my soil reports that if it's a sensitive clay site and you're going to do an excavation replacement, I'm going to ask that they cut that final cut with a backhoe with a smooth edge bucket. I've just seen too many times where an excavator goes in there and he's cutting it with scrapers and he's crashing the subgrade, he's rutting it up, and then it's just a lot of extra excavation. So sometimes I'll say, look, this is sensitive enough. Cut it with a backhoe with a smooth edge bucket, load it into trucks, and that way you're not disturbing it before you start to fill. And that's happened on a few projects where the excavator had to come back and do an extra 2 foot of stuff that it shows the wrong equipment. And that's where I can't dictate that. I'm out in the field, but Ryan, superintendent.
I can. During our post-bid reviews, that's some of the stuff that I get into. And you guys represent chief, superintendents represent Hurry, and at some point there's got to be a little bit of a balance. And sometimes I can raise the flag that the methods and means that this particular contractor is proposing is going to bring risk to Ryan companies. Are they really the right contractor to use? So if you can't get them to really reevaluate how they're going to attack a site, maybe you better go with contractor fee. And that's what I'm here for, is to help you with that.
Hey, you getting enough heat?
Yeah,
good. I noticed you went back twice. I didn't buy though. We're just going to bring a box over. This is, if you remember Larry's slide where I interrupted and I said, hey, there's an open field here. Something doesn't look right. I had a job in Plymouth at GME where it was near a highway interchange. And this site had pockets of trees, mature woods, areas with nothing but like little popple trees that are all about the same height. That giveaway too. So we drilled borings, and it was for an architect. He said, I just wanted just a general overview of this piece of property. Give me borings 200 to 300 foot spacing. I just want to know what to do. So we did the borings, and we did some research, and we said, this site was used as a borrow area for the interchange. So you're going to have areas of pockets of fill that we don't know where they're at. Be aware of that. We wrote that in the report because we found some borings with 20 feet of fill, other borings, nice natural soil. So anyways, we don't hear anything for 2-3 years, and all of a sudden we get a call from a developer. He's working on the site and he wants us to do testing. Well, what happened was we drilled, for example, these borings are 300 feet apart. We didn't find anything here, we didn't find anything there, but in between was a nice, neat cut pit where they borrowed for the highway. And they backfilled it with topsoil, trees, you name it. It was thrown back in. And the guy who the developer who purchased the land said, hey, I relied on your report, and I'm having to do all this extra earthwork correction, and I didn't budget for it. And we said, hey, we didn't even know you were buying the land, and that first report was real clear that it was preliminary. We warned you about borrow pits. I said, if you would have came to me and said, I want to buy this piece of property, I would have said, okay, this piece of property has got some issues. We need to do some more borings, some test pits, and then even then, as you say, instead of killing the deal, you got to go back to the guy you're buying that from and say, I'm going to have some extra earthwork costs here. Negotiate price of the property. They didn't do that. They just bought it based on some information that wasn't even for them. So the point I want to make is the soil reports tend to be used by a bunch of different people, all with different agendas. But Larry knows enough. He knows the red flags that I'm sure if you would have saw that report, you would have said time out.
Well, we do that a lot on the big retail deals that we do that Brian and I have been involved with over the years. We do a scattering of borings. We may take some specific borings for the Target or the Home Depot that we're building, but we've got tons of outlots that just maybe have 2 or 3 on. And some of the mistakes that we've almost made in the past is not doing a site-specific soils report. So if you're going to build a PetSmart or whatever, you've got to get the geotech guy involved and do a site-specific soils report for that particular parcel. Keep yourself out of trouble. It's I hate to downplay your expense and whatever, but it's cheap insurance, to do that. We ran into this very thing on the Gander Mountain that we built up in Forest Lake, Columbus Township. You remember that was the old trout air site. I don't know if a lot of you haven't been around, but they had all these trout ponds over the years that I took my kids up there. I had $75 worth of trout in a bucket before I could get the car locked up. But and that's what that was. It was an old trout pond that had been backfilled, and we literally drilled on either side, and that instituted a want and a need for us to go back and look at sandborne maps, to go back 20 or 30 years. It's just part of what we do now. You're not going to get burned twice, hopefully, but so part of what we do is we go back and look at sandborne maps, and if we would have gone back to 1969, we would have seen that trout pond, and hopefully it would have flagged that there's something going on.
And Larry will tell you this is how an earthwork guy is going to estimate.
Yep.
This is what the real condition was. He looks at this boring and he sees 3 feet of fill and 20 feet of fill. He kind of draws a straight line to get his volume calculation.
Yep, sometimes we get burned, so we've got to be a little bit careful about contingencies. Sometimes it goes the other way, but more often than not, you've got this situation, and you can either go with this risk, going into the job and say, look, this is the amount of material that I'm going to put into that guy's contract. We're going to have some contingency dollars in here for that. Or before you sign that contract, you can come out and take some test bits and see what it is you really have, and tighten up your scope. It just depends on what you want to do. I would recommend, if you could, come out here and verify.
And particularly like on this is from that kind of that site. If you have a site that for whatever reason you got 20 feet of fill here, 4 feet of fill here, 4 feet of fill here, and there was no building there or anything, you got to say, well, something's not right. Versus a site where you got a pretty uniform 2 or 3 feet of fill over the whole thing, that seems to make more sense. But when you get radical differences, you got to say, why is there 20 feet of fill on the field?
We're going to talk about test bits versus soil borings here that we get to. This is a classic example where you want to do test bits.
So to get the sample, you use a drill rig with this is an automatic hammer, it's a 140-pound weight that drops 30 inches, and you count the blows to drive it every 6 inches. This is the sampler right here, and Al's got the split plume sampler. This is what the guy back in the lab is looking at, for how much soil he's classifying to give you that boring log. And so what you see on a boring log, pieces of brick, pieces of concrete, pieces of bituminous, all he's seeing is what's going to fit into the end of the spoon. So you don't know if that's a 5x5 footing that the split spoon bounced off of. So that's why Larry and I are going to talk about test pits sometimes versus just going with borings. But from the boring, what we're going to get is a summary of the soil, bedrock, groundwater conditions. We get strength, compressibility, and this is what we're writing in our report. This shrink and swell, this is plasticity for soils. It's not what he was talking about for the volume calculations, 2 different things.
We've got some nightmare jobs in Texas if you want to know about swells. I can talk to that until we
Yeah, some clays got the potential to swell. We don't have too many of those here. Very rare that we get what we call a fat clay or a CH clay. Typical boring log. This is from Sage. It just is basically a chart of the soils with depth. You have your N values and your flow counts, the moisture contents. In that top 7 feet, they were running 24, 28, 26. And again, that's what the earthwork guy is going to be using for cutting and filling. We were a little worried about that, but the way the year played out, it turned out not to be a problem.
The earthwork guy is looking at depth of topsoil, where the water table is, and he's looking at the flow counts. The flow counts are going to tell him what he can use and what he can't use for equipment. If you're running on a clay site with flow counts that are 6, you're probably not going to run scrapers across it, especially with a high, moistures in the water table pretty low. So what the contractor's looking at is, you know what, this is an excavator and a rock roll hauler job. So whether they're smart enough to look at it that way, they should be. They're not going to be in business very long.
And this boring was drilled in May, but when they did the earthwork, which was end of October, November, the site had dried quite a bit because we went into a drought.
And so what the civil group needs then out of these basically recommendations from Tom on pavement thicknesses and so forth, and bearing values for the structural engineer. What kind of strength can we get out of that soil? Is it 1,500 PSF? Is it 4,000 PSF material?
Larry, just one lesson learned in New Montreal too. Your elevations, you can make sure you're coordinated with your survey with your where your borings are. You had an elevation on. Go back to that slide, and you got an elevation up there.
Yeah.
We had an issue where we weren't quite. We were working off of a preliminary site survey, and when we got the final survey, it really threw off what our exit elevate. We're off about a foot.
Well, I got to say this. Ryan does this right. You guys are probably one of the few firms I work with that really does this right. Whenever I do a job for Ryan, you guys have your surveyor shoot those boring locations and get the elevations. It takes all the air of us doing it. We're not surveyors, and so you get an exact location of that within 2 feet, and the right elevation, and it's locked into your document records. It's the way to do it. So keep doing it. That's the best way to do it, because otherwise you will, like Dave said, you'll have a problem. Or if we're just shooting a temporary benchmark that gets wiped out, and where it was plus 100. What was this fire hydrant over here? That's not there anymore.
Especially if you're in a hostile environment. I don't mean hostile environment, but you're working in the middle of Indiana and you're just another jerk from out of town. You don't have contractors out there that are looking out for your best interests. They're looking for things like that to get the extra book out, and it gets expensive.
So just, again, we talked about test pits. The borings are going to give you good strength information. You get the test samples. You can get the greater depth in the test pit. But the test pit can give you that big view of, particularly if you got a rubble site. If you really want to know what you're going to be contending with, or if it's potentially contaminated. When we see something like ash and cinders, the red flags come up because that's usually contaminated.
And test pits also, just as a rule of thumb, if you're planning on using any of the material on site, sometimes we like to bury the excess topsoil in the ponds, generate more cut that way. If you're ever planning on using a site, in that manner, you have to dig test pits. You just need to know. Don't guess.
And then just quickly, a piece of cone. Piece of cone is just simply, instead of a boring, you're pushing a instrumented rod tip into the ground. The truck's the reaction. The rods are fed inside the truck. What you get from this is strength information, pore water pressure. We can use this to calculate bearing capacity and settlement. And you interpret the soil conditions on the far right there, because what we do is we look at these parameters and we can figure out what the soils are. Because you're not getting a sample. You're getting just readings. There's no samples obtained. Advantages, you can do 3 to 4 of these versus a boring. So you can get a lot of coverage on the site, particularly if it's a deep foundation site that you're going to go 100 feet. Doesn't work well if there's a lot of boulders and cobbles. No, I got a couple of minutes here that I want to talk about Sage. Here's the project team. I didn't put on the orange, red, brown. But this was part of it. I want to talk about this because this was a site that some pre-planning went in that I think really aided the job. And all these folks had input in this. I'm going to have a little slideshow of how the footing construction went in winter. That was pretty cool. But here was and Mark, feel free to interject on this one. But it was 300,000 square feet. They had very heavy floor loads, very settlement-sensitive machining operations for the glass tinting because it's electro glass tinting. And so the floor slab was the big deal on this job. I mean, the tilt-up, the precast walls, the building shell wasn't that much of an issue. It was how this floor was going to perform and how it looked. So he had a very tight schedule. It was a clay site down in Faribault. And they were going to, the way the contracts and everything struggled or whatever, earthwork didn't start until, what, the last week? Halloween, wasn't it? And so they had a window of 2 weeks to get a 300,000 square foot building pad prepared before winter. And this was the schedule. So all those folks, we got together and he said, look, the owner complained that his original building, when they went to do the floor, it was just a mud hole inside. After he got the building enclosed, they had to end up hogging out soil because it was a clay site, stuff got wet, it came through a winter, the typical nightmare scenario when you get a building enclosed on a clay site and it's the whole winter had gotten wet. So we said, okay, well, what can we do? And this ties into where the elevations were set for the floor. So what we came up with was we were gonna build a crushed concrete floor slab base from the get-go in the fall, not after the building is enclosed, but we're going to prepare the site with this crushed concrete floor slab base. And this was going to give a real firm base to work off in the spring thaw. When the building was enclosed and shed water, you could just dig little drainage channels and pump like the building out. We're going to drain the subgrade with sand, and then so by doing that, by bringing in these quality materials, the added benefit was it allowed the structural engineer to design a thinner slab, and you had this really stiff modulus of subgrade with a very high modulus, which really helped that slab perform.
Let's go back to that. There was a sandwich in there. There was a layer of sand underneath the crushed concrete. That was a drainage layer.
Did you ground it all, or just
left it flat? So we installed drain tile, and we'll show you a picture of that and how we worked that.
So here's your clay site in the fall. Okay, so you can imagine you prepare this in mid-November, it freezes, and now you're going to work on it through the winter and into the spring. And you all know what happens when it comes out of freeze thaw. It's a mess. So this is what we did.
Sand layer right here.
Here's your really clean sand. It was 5%, passing the number 200 sieve, really clean. And this was placed over the clay subgrade that was smooth drum rolled. And here he's dumping the crushed concrete class 5 on top of it.
It was a foot of class 5 and
8 inches of sand.
8 inches of sand.
So you had 20 inches of granular. And so what we did, okay, so you're going to get water into the sand, so how are you going to get it out? Well, they trenched this in, and they put in these drain lines every 100 feet that were down into the clay. You had your sand over it, and then your crushed concrete, so that any water that would get into the sand would get out.
So the takeaway from this is it worked fantastic. It saved the job. You know, it's just one of those things that I can tell you would save the job. You can't know that because we weren't, pocket deep in mud and so forth. But we've used that technique in West Jefferson, Ohio. We're going to use it in Shreveport, Louisiana, both, very moisture-sensitive sites. And it absolutely saved the West Jeff job. Did not lose any time because of this method that we used here. proved it out, and so lessons learned.
And
Good lesson.
then the group got together, and Mark can attest to this. We said, well, okay, they're going to have a main utility run in this building. Well, usually what happens is you get your floor slab subgrade in there, they dig in the utility trenches, you're mixing the clay with the sand, you got a mess. So they said, well, we know where they're going to go, so let's do a defined run. And they subcut this run and then backfilled it with sand so that when they came in to do the utilities, what they were going to be excavating through was the crushed concrete and the sand, and not mixing it up with the clay. And this slide shows you the layers. Here's the clay subgrade, here's the sand, here's the crushed concrete. Again, and so when it was done, this is how it was left the second week in November. This is the crushed concrete surface. You have your trucks. I mean, this was a bulletproof pad. And so what Jim Odegaard told me, the steel erector, told him in March, this was the only site he could work off of because all the other sites were shut down at a real region. It was all those other sites were just impassable. This site he could work off of. He said he didn't get his structural steel. If the structural steel didn't get muddy, he didn't have to wash it off, so he saved some costs there. And the other thing that happened on this site, in the next little slideshow on the footing construction, there weren't the typical soft areas around each footing pad because they did the neat dig approach. And Lou Longmire, who was my tech out on the job, shot this slide sequence, and this is going to be kind of like the birth of the footing. They were going to neat dig these footings. So this is in January 2011. They laid out the footing. This is actually a saw that's going to be sawing the square shape of the footing because you're not going to form this footing. You're going to be doing what we call a neat dig. The soil is going to be the side bank. This is a picture of the wheel that was cutting it. So now the backhoe comes in, you already got the part that's frozen because the frost had gone down through the crushed concrete and into the sand, but it did not freeze into the clay subgrade below.
And this was all born out of a superintendent that just didn't understand the word no. It just worked until he came up with the methods and things that we all thought he was crazy.
This is the crushed concrete. Here's the sand.
Is there a way to neat dig in warmer climates?
Sure. Oh, yeah.
Twice.
It's much easier if it's warmer. You don't have the frost issue. But Jim Odegaard decided, no, I'm going to do it this way, and I'm going to save my frost waste. So here he's just supporting the rebar, and the footing is poured up to this depth here. So it was not poured against any frozen ground. It was poured against the unfrozen clay bank. So they laid it out Monday morning. This is Tuesday. Tuesday afternoon, they're pouring. They pour it up to that marked line. They're not going to be pouring up against anything frozen. Blanket it overnight. The next day they come back, now they're doing the column pier because these footings were designed to be 4 foot deep to get below frost through a winter condition. These are interior column pads. That's why they're deeper than normal.
Now, would it matter if the clay was frozen or not?
Yeah.
Yeah. We probably would have had to put insulation on. Then Mike Jones pre-made all these heated enclosures. So that pier was poured the day after the footing. Now he's putting on all these heated enclosures with one heater and a pipe underneath the side for each one. Tent city. So he's heating all of these overnight. So this is Wednesday now. And what he's doing here is the excavator had a source of unfrozen crushed concrete, so he's backfilling around this with unfrozen crushed concrete right on top of that concrete footing. There's no space around the footing, so you're putting 2 feet of fill on top of concrete. And so what happened, once this fill was placed and compacted in an unfrozen condition, when it froze and it came out of freeze thaw, it was still in a very firm condition. And the steel erector said he's never been on a job, this is a week later, he's never been on a job where he didn't have a soft spot around each column. Around each column was just perfect.
And it all goes back to the owner allowing us to put that sand layer, green tile, and the class 5 down. Because everything that we did to this pad, as we were coming out of winter, all that snow, all that frost, was able to melt, hit that sand, and the green tile got it off of there. It was, like I said, it's just something that you really can't put a finger on. We know it worked. And the only way that we can tell you that it worked is to go out and build that same job and not do that, and we'd see the difference.
So Larry, just following up on that point, how did you quantify that with the owner, and how did that dialogue go with the owner? Because obviously they're willing to invest big dollars in a bulletproof.
Gary, the only thing that really saved us is the owner went through a nightmare with the facility that they were in down there already. Is that correct, Mark? Yep. And we kept hearing over and over, we don't want to do this again. This is, he knew what kind of a site he was on. Basically, building at the same time of year. Says, this is what we can do. This will mitigate your risk. We had no idea. We did have a pretty good idea how it was going to work, but this worked way beyond our expectations.
And then the added benefit was he had a 20-inch granular section below this slab to help with the settlement considerations. And for the working surface for the concrete guys, drive whatever you wanted in there. The ready-mix trucks, I mean, it was wonderful. But you had a 20-inch section, and that crushed concrete actually started to re-cement after about 5 months. It actually got even stronger than just in a regular compacted state. So now, Al Hartley is going to talk about bituminous.
All I know, surprise. Just a quick picture of my lab. It doesn't look like this anymore. It's crammed packed. We're expanding unbelievably. We get in the heart of this. Right now, what MnDOT's telling me is this is all they're supporting from now on. This is what you guys are used to seeing, these Marginal Mix Designs. If you do a Marginal Mix Design, you get a sample pot that's this size. This is the key. This is the size of pot you're getting. Now you're doing super paved designs. This is what we're making. So it's a little bit different, and it's critical when you're taking samples or asking for people to do tests for you, because if you take a sample to do this, you don't have enough to do this. Pretty straightforward, huh? What MnDOT's telling you right now is that the gyratory symbol is SP, stands for super paved. The WE is going to be wear or non-wear. That's it.
NE or WE?
WE is wear, your wear course, and NW is non-wear. That's all you get. You don't get your binder. You guys that done before, you had a base, you had a binder, and you had a wear. MnDOT doesn't do that anymore. It's either wear or non-wear. The key is where it's at in its relationship to the very top surface of your mat. Anything from the top surface down 4 inches is always going to be considered a wear surface, a wear mix. The next letter you see is B. That tells you your aggregate size. 3/4, ½ inch, 3/8 if you want it. Most mixes I recommend for you guys to use always be a B or a C is bigger rock even. So if you got a really heavy load, consider using C rock, which is 1.5 inches type rock. The next number, 5, tells us what gyration. The higher that number, the higher traffic load you can have. So if you're doing your target parking lots up in front, look for a number to be about, it's typically car. Everybody tells me it's just car traffic, and because I'm I'm too old to realize it anymore. It's like, I just let them think it's okay, because how many cars do you see in a Target front parking lot when you're constructing it? There's more trucks than there are cars, and they'll beat your parking lot up. So you're going to have traffic level 5 is your interstate. The lowest number you can get in Minnesota is 2, which is what I call your cul-de-sac. Your neighborhood cul-de-sac street is a 2. So if you're in a Target parking lot, you're looking for a level 3 or a level 4 type, depending on where it's at in the parking lot. You know, the back side of your parking lot, you know, loading dock area, you're looking at 4s. And out front, your parking area is a 3 is a pretty typical number. The next 2 numbers, 40, tells me your air voids. If it's a wear course, it's always going to be 40. If it's a non-wear, you're probably going to be looking at 30. Okay? The last number tells me what type of oil you want to put into your asphalt. It's either 5828, 64 minus 22. There's a whole selection. I'll show you the slide. What this tells me is this down here is Marshall Designs. MnDOT doesn't support anything Marshall Design. I'd say 80% of the states in the country right now are getting away from the Marshall Mix Design, or if you're out in California, the Beam Design. Everybody is going to the Marshall or the Super Pave Design, and starting, I think California is 2014, they won't do anything unless it's Super Pave. So,
Al, when I think of super pave, I'm thinking of some high-tech oils and so forth. Is that true?
That's part of it.
Okay.
Part of your structural strength you get in your pavement on your parking lot is going to be the type of oil you select when you do the paving. And I'll show you a slide with the different types, some of the different types of oil. But when we talk super pave, we've just gone to the next level. The old Marshall Mix Designs, they use gravel, usually the leftover gravel from a concrete pit. If you know anything about the history of concrete aggregate, they've always used wash, clean, solid rock, and the stuff they couldn't use, they'd use in asphalt. Now, in the asphalt industry, they've decided we got to make a product that lasts as long as concrete, and it does. It will last as long as concrete and longer. It's just they're using better aggregates now, so we're not using the cheaper aggregates to make asphalt anymore. You're getting a better quality aggregate, and you've got better control over the aggregates. One of the things I'm constantly hounding people on job sites, and I will not pick any one person, it's every job site. When you guys, it's funny because you guys will spend a lot of time, you'll go through your soil work, you'll go through your site prep, you'll spend thousands of dollars, millions of dollars to build a building, and I talked to some of the target pavement people. The last thing they worry about is their parking lot. And in the last couple of years, they've realized that they hurried up, they built this beautiful Target building, they had Walmart, you know, these big stores, and they realized when they're all done, 5 years, 6 years later, their parking lots are falling apart. And the first thing their customers see when they come into this really nice building is a parking lot that's falling apart. The way you protect yourself is you gotta, every ticket that you get from an asphalt. So when you guys think about concrete, everybody always looks at what's the strength of the concrete that they put in their footings. They always look at what's the strength of concrete in their piers, their decks, and everything else. They want to make sure they get the right concrete. It's the same thing for asphalt. You need a mix designation showing up on your ticket, telling you what mix they're giving. There's also a mix design report number. And this number is critical because this is the number that the local DOT will verify that they've checked this mix and yes, it does meet the requirements you're looking for. You want plant location. You want to know if the plant is certified in Minnesota. We do a certified mix. So if MnDOT okays the plant, you can buy pretty much anything you want from the plant. You want a truck number and you want your job number on it. And as simple as this stuff is, it's amazing how many jobs, we just had a job come in, they told us, the ticket said one thing, and then they came back and told us, no, it wasn't that, it was a whole different mix, and we got into this deal of, we've already tested it one way, we can't test it another way, based on what your ticket said, and what it comes down to is, did you guys really get what you paid for? somebody did it for super pave and they put down an LV mix, they just made a lot of money off of that. And then they'll come back and say, well, there's really no difference, but the reality of it is there is a difference.
Say, Al, when he says that MnDOT doesn't support those mixes, what that means is they don't even list those in their new specs.
Right.
MV, LV mixes aren't even listed in their specs. They don't do any testing anymore on them.
So there's all their equipment. They don't even do Marshall designs anymore. Marshall verification has gone.
So if you don't see an SP,
if you go to Wisconsin, everything is what they call super paved. If you go to North Dakota, they do some super paved. There is a little bit of Marshall design, not a lot, but for the most part, the 5-state region around here, and through most of the country, everything's going to go to super paved. If they haven't already, they're within a year or two of going that way. The key to remember when you take samples for a super pave, this is the only thing I think concrete's good for, is they give you these 6x12 cylinders. And that 2 concrete cylinders, 6x12, filled with asphalt, will give anybody who's running the test enough material to do tests on anything super paved. So you get 2 of these pots and you get your chemical extraction gradation stuff, all of that done with 2 6x12 cylinder molds completely full. Not fill them up when they're hot and then let them bounce around and then settle down and they drop this far. They've got to be completely full. That protects you guys. You get 2 full cylinder molds. Wherever you get that to, whether it's me or my competitors, that's enough material for them to do a test on for you. MnDOT spec, and I'm only going to glance at this quickly. MnDOT specs samples are held for 14 days or 10 days. And after that point, everybody throws them out. So when you're on a site and somebody takes a sample, and if you split the sample with somebody, you got 14 days to get your results back to make sure that if something doesn't line up or if there's something wrong, you can go back and still correct the problem with samples that are held on. Here's what this is. This is a gyratory compactor versus a Marshall. A Marshall compactor is a 10-pound weight that just drops. 50 times on each side, you turn the puck over, you pound it 50 times on the other side. The gyratory method here is completely, we take man out of it completely. You pour this mix into a big mold, you stuff it in the machine, and you hit start. I don't worry about anything cooling down, trying to do stuff faster. It's a more reliable method. I can make 3 of these, and I can have 3 different hammers, 3 different temperatures, 3 different mold material, and get different numbers. When I make 2 of these are usually within 2,000ths of each other for weights and bulk. So we've got better at reproducing the numbers.
And you're using those for what?
This is payment. This is cash.
For density.
Yeah. When you look at this, I use this to do my calculation for air voids and my volumetrics for when you guys figure out payment. So the closer I can get these samples together, the more reliable we are on our calculation. So what we have here is we have the gyratory. We just put it in this machine. It gyrates. It's at a certain angle. It's 1.17 degrees internal angle, and it puts a 600 kip load on it, and it gyrates the number of revolutions. Certain number of revolutions for each traffic level. So we have 30 gyrations, 40, 60, 90, 100 gyrations, depending on what traffic level it is. And that relates to what your parking lot is too. The other machine is we call a simple performance tester. That's the newest thing that's coming out that the government and the DOTs are going towards to figure out a better pavement. So it's just one of the newer machines that are coming down the line, and MnDOT's looking at implementing this piece of equipment to be used to analyze the higher volume road pavements or your parking lots to see how it will hold up to repeated abuse by trucks and stuff like that. So it's just something new that's coming up for you guys. So this is one of the new calculations, and that's all it is. When you do this, the only difference between the regular testing and new testing is this. All the other tests are the same. So I went from making this to making this. With these,
I just punch in the formulas based off the extraction gradation numbers. That's why everybody says they only want extraction of oil content, but you need to have pucks made so that you take the bulk of this and you can actually do the calculation and figure out the AFT, what we call the asphalt film thickness. And that's going to tell you how durable your asphalt is. You have enough oil covering the rock to keep it in place for you. Otherwise, if that number falls too low, you're going to have rattling, you're going to have all kinds of other problems happening. What are we looking for with the pavements in the new systems that you guys are seeing is pretty straightforward. Has your design been approved by somebody? Is the pavement clean? Tack coats, one of the things you're going to see in your parking lot, so you go to the second one. If you see somebody put tack coat down between the two layers and you see stripes, you already have a problem. Guaranteed. You need tack to be completely covering your pavement. If you see stripes, you're going to have problems. We have more tack problems this year than we have in years. As a matter of fact, I'm putting on the bituminous conference this year and St. Louis Park, and we actually have, I'm bringing in a guy to talk about tack problems because it seems to be getting worse. So the key is if you don't have a good tack coat, which is going to bond the two pavement layers together, you'll have problems. It'll happen sooner or later. More likely sooner than later. The next thing I have here is this is what you're going to see. These are two different contractors giving you two different mix designs. When you go and you get a mix that isn't a super pave, this is what you're going to see. The contractors give you their own designs. Now they may have been running them, they roll them over, but they're not supported. They've never been tested. They'll tell you they tested them, and they have, but there's no backing to this. You're at their whim. This is what they're telling you it will be, and there's no penalty for it. There's nothing in writing. If the gradation meets, fine. If it doesn't, they'll say, well, we tried, but we didn't make it. The airboys, they'll tell you what they want. They'll do it for super pave here. This guy did it for super pave. This guy did it, I think, as an LV. So if they make up their own design, there's no backing. My advice to you guys is tell the contractor you want it verified if you see something like this. If you see something like this, you know it's already been verified by MnDOT. And that's the best thing you can do. You see this number up here. It tells me it was done in 2012. It was verified by MnDOT, and it was the 10th mix they verified that year. And I'm not worried too much about it because this mix design, if you look down here, he did the original design in 2012, and it was the 7th one they did. So it didn't make it very long before they sent it a change already for this mix. So it's a nice way to track. MnDOT system is, some people will say, what are they doing? But at least they're tracking their mix changes for you. So you know if it's updated or not.
So our takeaway from this, Al, is we want to see a MnDOT.
I would say you want to see a MnDOT design. If you do not, I'd say tell the contractor you want the mix verified. And I've done that many times. Or you can call me, and I can see if I've run tests on the mix to verify if it is close to what they say they're doing. But you kind of want to see the MnDOT seal up here. I guarantee you're getting MnDOT verified mix.
Do most states do that, Al?
Most states will do something like that, yeah. Wisconsin has their system. North Dakota is getting into it. North Dakota, if you've been out there yet this year, I've been out there too many times. It is really progress, a learning experience in progress. And contractors will like to go out there and they'll tell you all kinds of weird stuff, and it has no basis. It's just the way they've been working out in North Dakota.
Well, contractors have their own mixes that have been verified that aren't MnDOT. So if you verify someone's mix, can they just take that forward?
Yeah, in most cases in Minnesota, most of these guys, if you have a problem, they'll show you a full list of tests that they've already run on the mix. I would personally stay away from the LVs and MVs from now on, if it was up to me, or any parking lot. And the only reason is because you have no backing on the spec at all. they'll tell you it's a MnDOT spec, but it's a MnDOT spec it's 20 years old and it's been dropped. So it hasn't, if you say MnDOT, it's a MnDOT LV spec or they call it 2350 spec, MnDOT, if you ever end up going to court, they'll tell you the spec's not there anymore, so why are you using it? I've heard one occasion of that happen. So, the MnDOT 2360 spec is an interesting spec. Cut and paste is what you see right now for specs, so if it worked good in 1985 and the designer cut and paste it, that's what you're going to get. You're going to have problems. It's time to update their specs for the most part. The spec in MnDOT is 2360, and the way MnDOT reads that spec is, if you don't want it, you got to note it in your special agreements or your supplementals or whatever you want to say don't do it. Otherwise, MnDOT 2360 spec says you do everything. This is the oil that you have, and I've talked with several engineers, and Dave Retner is my boss. He's our vice president. He's what we try to call it our asphalt guru guy. Okay. These are lists of some of the most common oils. 58 minus 28. It's not 58, 28. It's 58 minus 28. The first number is your high temperature, average high temperature in Celsius. The second number is the minus number for low temperature cracking. If you get down to Iowa, you'll see the 22s and lower. You get up northern Minnesota, they like the minus 34s a lot more. It's all about cost. Don't kid yourself. What's cheapest? 5828 is the most common. Why? It's the cheapest. It's the easiest one to get. I talked with Dave, and we've been saying this for years. This isn't new to us. If you're doing a parking lot wear course, I'd like to see you with a 64 minus 28 oil. That's just me. It's going to save you a lot of phone calls after you get out of the parking. After you get out of your building and you move. The number one complaint I get is scuffing in parking lot. It looks horrible. You see those little wheel marks. You see them in your street, parking lots all over the place. It's because typically with the new grading system on oil, it takes 6 to 12 months for that oil to cure before you'll stop seeing those scuff marks. Number one phone call I get every spring, right after the first hot day. Anything over 80 degrees, I get a call. Hey, my parking lot looks like horrible. My driveway's horrible. It's worthless, and it's scuff marking. And it's because the oil hasn't cured out. They use too soft of oil. So we recommend 64 minus 28 for your wear course on parking lots because it's going to eliminate that problem for you.
Does that affect running too?
Yes, it'll give you a better resistance to running. One of the new things, here's the core sheet. I'll go into this right now. You guys, everybody wants to know, did it pass or not? That's it. You guys use the standard, what is it, 92%? Yep. And that's based off of the GMM number here. It used to be percent Marshall. It's got to be 95% of this density. Now it's 92% of what we call the rice test, which isn't this, it's another test we run. And contractors get really mad with you because you'll get a super pave design and it says 95% Marshall and you're doing a super pave and they say, that doesn't make sense to me. And so then we have to educate the paving contractor who we really shouldn't have to, but that's how we work it. But when we do density, when you cut a core, you see somebody cutting a core on your parking lot, we call that money in the asphalt business because you're paying, there's potentially a penalty for density. And if you don't get density, you don't get parking lot life, and then you have all kinds of problems that develop. So if they're stick a core in a truck and drive around with it for a week before they bring it into somebody, guess what it's going to do? It's going to affect the density of that pond and whether you get density or not. Maybe you have density when they cut the core, but if it rode around in the back of a pickup truck or sat on the job site outside in the sun, now you're not going to get density. This is what I'm talking about, the Marginal Mix Design. give you an idea, if your in-place voids are 44%, your percent maximum theoretical or RICE test, you want 96%, and it's 100% of your Marshall pump. That's how it relates down to. It's the best slide that's out there to explain what you're doing. So if you want 100% density at 4%, that's this bucket. It's pounded, it's considered densified, got 4% air voids, we know what it is. If you want 95% of that, that's fine. But that's how the density chart works. Now people will say I'm cutting my own throat here, but every contractor in Minnesota does their own testing on their asphalt. If it's over 300 tons, it gets tested from an asphalt plant for the day. If they make 300 tons of mix, it's supposed to be tested, okay? That saves you guys and your customer a lot of money. Because you don't have to have, they're going to test it every 1,000 tons, but what you do need to do is verify what the contractor ran and what we checked it to verify it's the same. That's what these two columns are. This is what the contractor got. This is what the companion sample was. It's good. The next one he didn't have to. The next couple he didn't have to do companion samples on for that day or whatever. So I'm not saying, we see a lot of the stuff where we get specs that say they want to test every 500 tons of mix produced. I would say if you took one sample per mix type per day on your project, you would be covered on most paving jobs. That saves everybody money. I know I could be doing 1,500 on a big target parking lot. I could be doing 4 or 5 samples a day. It doesn't do anybody any good. I'm not about taking your money from you or your owner's money. I'm about a good relationship, making sure you get the right product down on your parking lot to help you move forward. I'll make the money back later on in life. I suspect people will come back and be happy with me, and that's already proven. My department's grown tenfold in the last 2 years just because our attitude is let's help you guys get a better product down, and then you'll come back with more work. It works out really well for me. Seems to be working well. One of the other pieces of equipment that you guys are going to see coming up, this is a foamed asphalt machine. And I put this in there because I'm the only one that owns one in the state of Minnesota. Everybody is going to foamed asphalt, okay? I just got off the phone with Commercial Asphalt. They bought like 9 of these units for 12 of their plants. And what foamed asphalt is you put a little tiny bit of water into the oil, a little bit of pressure, and the oil will expand. So if you've got 500 grams of oil, which in a 5-gallon pail is, nothing, you think 500 grams is about half a water bottle, maybe, give or take. That, and you heat that oil up and you squirt a little bit of water in there, it will bubble up to 5-gallon cans completely full. And what that does is it enables the asphalt to coat the aggregate more evenly and better. It also is like, if you think concrete has air bubbles, it's these air bubbles, it makes it so you can work the asphalt longer to get density. So, you've got a couple issues that I've seen with it. If they don't get density and they're paving in the summer and they pull off the site and then you pull it onto the site and you have like truck traffic on there and it's still warm, it will still densify, so you get ruddy. So in this case, you want to make sure that they get density in the field. That the mix is tested all the same. There's no difference in testing. It's actually a really good process. The thing you have to be aware of is just because they got foamed asphalt doesn't mean they can come on the site with less equipment to get density. It just gives them more time to get density if they need it. Does that make sense? So what I've seen so far is a couple of contractors say we're using foamed asphalt or warm asphalt. We don't need a big huge roller. Well, technically you do. You still got to get density on that pavement. A little roller won't do it. A littler roller won't do it after with more time. That's pretty much what I have for the quick update on it.
So the takeaway from from this guy is I guarantee if you're going out to bid for 4 different asphalt contractors, you're going to get 4 different prices. And the reason is that for the most part, they're buying their asphalt from commercial asphalt, so the cost is the same. They're paying their men the same. Their equipment costs the same. They're looking for an edge to be low, and they're looking for your ignorance as their edge to be low. I'm not an expert at asphalt at all. I'm the first one to say these numbers don't mean a whole hell of a lot to me either. Keep Al involved. Make sure you got it spec right. Not only that, make sure you're buying what it is that you spec. And we get fooled a lot. We still do. So be careful.
I'll leave some of my cards here, and I tell everybody this. I don't care if you're working with us, if you're working with our competitor or somewhere else. Take the cards, call me if you have a question. I'll spend 15, 20 minutes talking with you guys for an hour, hour and a half. To me, it's about getting the right situation for you guys. That's my goal. It's asphalt to me. That I'm president of MAATT, which is the Minnesota Association Asphalt Paving Technologist this year, and my goal is to make this work for you guys. It doesn't matter to me if you're working with Ron, what's Element, SDS, or somebody else, Dave even. You can call and ask me a question, and you can fire me, hey, this guy's telling me this. Does this sound right? I'll tell you if it makes sense or not. So,
Well, if this works, guys, some of the thoughts that I had, we videoed this. It's going to go out on the green for other offices to watch. I'm thinking maybe the next one of these that I'll do is going to be ground improvement and some deep foundation techniques that we've used over the past. If there's anything that you'd like to hear talked about from a site standpoint, reach out and be happy to look at it. Not sure that how well received this is going to be in the other offices. Thank you. Questions?